the which are not found. For example, 1001, it's not showing up here. The reason is 1000 is already there in the second table. 1002, which is Priyanka. If I look at this entire data set, I don't have such name or such employee ID or such salary. So let me get the output. Now, if I go at a third one, that is 1003 and Niliman 5000, if I look at all this data set, I don't have that. So it's clearly getting from the left table, which are not found in the right hand table. So that means out of these three rows, Monty is similar. So it's just detected that row from these rows and displayed only Priyanka and Nilima as an output. That's about it about the except operator. So if the same case goes with even when you're trying to use employee names here, sorry, when you're using except, let me use except, that's it, testing two. What you're trying to do in the second part is we're trying to say, can we still has the ability of picking up the two columns? Yes, it has. Will it has the same ability of putting a different columns, but still the data type is not matching? Will it retrieve? It will simply fail. So all the set operators are blindly following the same kind of rules what we understood in the initial stage. But what happens, this select quiz, you must be having this question in your mind now. So what happens if I try to interchange the tables? Okay, you are more or less talking about table A means left, table B means right. So can I interchange it? But now we are not understanding which is left and right. Maybe if you put like this, you'll understand which is right and left. Okay. Now look at this. Table A is left. Table B is at the right. So let me run this again. No problem. It is getting 1002 and 1003, which is the right answer. So what if I change my table as B and this table as C, which is a different scenario, which I'm trying to understand this, because that statement is very clearly insisting all values from the left hand table which are not found in the right table. So now what I did is I reversed the table name. Okay, left table I put it as a right table as a left. Now let's, before we look at the output, let's try to visualize what should be the output. 1004 record. Now this time this table B is our left table. Okay, just imagine it should be at the left side, but it's still at the right side. Okay, now it will try to check, is this guy is existing in this one? No. 1005, is this lady existing here? No. Seema is existing here? No. 1001 Monty is existing? No. So how many rows we are expected to get in the except? That is only 3 rows or 4 rows. Let's see. Now when you run this, you end up getting only from left hand table which are not found in the right table. So that means 1004 nowhere I can see, 1005 I cannot see anywhere, 1006 also nowhere I can see, 1001 of course I can see, that's why it's not displaying. Now intentionally I've changed the row table from A to B and B to A. Guys, the operator what we are learning today is not just specific to SQL. When whichever the technology which you are using, which is more relevant, where you are trying to join two tables, or when you are talking about the tables, when you are trying to analyze the tables, whether it is an Excel using Power Query and data model objects, okay, data model object, or you're using simple MS Access, which is a desktop application, or you're using huge server like SQL or big data tomorrow, or BigQuery or tomorrow, or MySQL, Oracle, Portugal SQL, SQLite, whatnot, 50 plus all relational database management system, and one more which is really currently in use, that is Alteryx. Okay, that also use the same kind of operators again. The logic is always going to be remain the same. If I say union means, yes, it does the same in every kind of a technology. It does the same. The only thing is the way you write might be different, but the subject matter will be the same forever. So that's why my intention is always to understand the concept, so that tomorrow if you're learning something new also, it should not be taking much time for you to understand those things. So having seen 4 examples for each operator, now it's very clear what should be my mindset when I start designing a query when it's related to operators. So as a bottom line, you need to remember, if we break, let me put this note as well. If we break the rules, set operator as simple as that. That's it. This is a golden rule. Last rule, if we break the rules, operators will not work because it's all depends upon the operators. The first operator, let me revise again because it's applicable to all, right? So let me put these rules at the top. Yeah, these are the rules here. And let me rearrange this. Union doesn't have this. And next we have seen this, yes. And intersect, then we have seen except. All right, so after looking at the set operators, which works with the union, which removes the duplicate, and when you're working with the union all, which will try to get all the records, irrespective whether it's a duplicate or not, it doesn't matter, it will get all and merge together as a single result. That is what the operator says. It will simply say, combine two tables, I'll give you a single result as a one data set from different multiple tables, giving as a single data set. So in the same sequence, we have something called intersect, which is only getting the intersect values. And we have something called except, which will get from the left table, which are not existing in the right table. So that is what the except is talking about. Now let's see what are the joins and it types and everything. First, before getting into joins, there is a one important concept which we need to understand, which you've been already working. That is the types of data set. Okay, types of retrieving data from a data. So what is the first type? I know one query because the kind of knowledge I gained from the last 8 or 9 weeks. The select is the keyword or the command which I use, which is a DDL command or DML command or TCL. It comes under the DQL, data query language. Some people use select query under DML because they think it's a manipulative query which will manipulating the data and trying to give the result. So either you can term it as under a DML or DQL. DQL is always better. You are separating that select command as a separate category itself. So there are totally 5 categories. Under that, the first one is saying that is selection. Selection is nothing but we are always selecting the data, not just saying simply select star from table, but we are also using what? That is with where clause, where condition, right? So whenever I'm using a select query, what I understood is if there is a single table I'm able to access by using select, and whenever I want to filter the data, I'm using a where condition. Whenever I want to order something which is not ascending, I want to make it descending, I'm using order by. When I want to group by like a pivot table, which you have seen, that is I'm using a group by keyword clause there. And if I want to on the group by, when I want to filter further, I'm using a having. So we know all these clauses, okay, which is meant for a single table. But having said that, when you want to access a multiple tables, then joins comes into the picture. So far I know only selection part. Now let's see what is the second way of doing it. That is called as technical word projection. Okay, without 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 condition using select statement. Yeah. So what is the difference between the selection and projection is? Projection is always the first query what you learned in the very first session. That is select star from table. That is pretty straightforward, which is retrieving the data for you, which is without any where condition, without any other clauses. That is a pretty straightforward query, which is also retrieving the data but without any conditions. So that is called as a projection. This is very, very important. These 3 terms you'll not find anywhere, but when you speak in the interview, when it is something related to a retrieval part, you can categorize these 3 terms. One is selection, one is projection, and the third one goes is joins. Joins, I can use conditions, I can use without conditions, I can join, I can select data from not two, you can say multiple rather, multiple tables. Now, if you look at all these three statements, what I've written for easy understanding, selection will always select the data from your raw data, whatever the raw data may be, but always ensure that it is a single table only. Projection also works like getting the data from the table, but again, it is a single table only. So the first two, I literally fail when I want to get data from multiple tables. I don't have any choice. That's it. That is called as the selection and the projection. So when you talk about the joins always facilitate you getting data from multiple tables, because we can't expect the entire organization working in a different departments, different portfolios, different streams, putting all the information into one table. You will never find such kind of environment. You'll always see different tables. Even a small school also, they will try to maintain two different tables, one for what are the subjects they're teaching, what are the teachers information, one table, and what are the different books available in the library as a separate table. So if they want to see as a single data set, they will combine all these three tables into one to see the final output so that they can do further analysis. So joins plays a very, very, very important role, having understood the selection and projection. So these are the very advanced topics for which we must and should have the knowledge of the select queries, because what all I am using is nothing. What I learned in the select queries, I'm going to combine with joins here. Okay, let's see, break it down each join and understand the very first join with 100% clarity, which will make life very easy to understand the rest of the things. Okay, join is basically performed, okay, whenever you see more than one table, then we are going to use this join. Okay, we are going to use join. So the word itself is indicating you are trying to combine something, right? So it could be a two tables or multiple tables, does not matter. So here, again, we have two methods. Actually, you'll not find anywhere again this topic, do methods. Okay. All right. So two methods in joins. One is ANSI model. Okay. ANSI method format. ANSI, as we know, American National Standard. Okay. What it says is, in this type of, let me write the next one, non-ANSI format. So in this ANSI format, what are the different type of joins available? Under the non-ANSI format, what are the different types of joins available? Try to visualize everything in, visualize whatever the information which I'm passing now, and try to show more on Excel, more on anything by drawing some picture. Try to get all this information, and practically we can do 1,000 examples, doesn't matter, because we need to understand the concept, how literally a join, one table is talking to another table by using these joins, and how exactly they're merging together, what exactly the data I'm looking for, what kind of left table should not change, but the right table matching because I should get, what kind of join I should use. This kind of picturization, if you want to get in your mind, you need to get everything on the paper first. That is ANSI format. What is ANSI format? This is ANSI format is also called as a new style format of joins. Format of joins. Okay, this is you can guess now, it is an old style of format of joins, which are not that popular, but still let's try to get the complete hands-on understanding what are these two types. Okay, they're not that popular. ANSI format is something which is more in use now, and currently everybody is using throughout the world. So let's see what is the first one. In case of a ANSI format, what happens is it will simply the same concept again. It's trying to join two or more tables. Okay, it's going to join two or more tables with, this is an important keyword which you need to remember, on. Okay, on is a keyword which is going to be used. Okay, when I'm trying to join two tables, I need to use a keyword called or, on, on. The way I use, if I want to filter some data from a table, I use a where as a clause. Okay, if I want to get top 10 information, I'm using a top as a keyword. So here I'm going to use on. How to use, we'll see a little bit later, but let's try to imagine everything now. We are joining two or more tables with a keyword called on. In case of your non-ANSI, we are going to do the same job, but we are not going to use on keyword. Rather, we'll use where keyword. This is quite interesting. Joins can also be joined by using a where condition. And this join also can be joined by using on keyword. So we'll try to see in action, but right now only theoretical. Okay, the first and foremost, what we have in joins is we have something called inner join. Okay, try to give more and more information, just not saying inner join. Inner join can also be called as a simple join actually. Okay, people think it's a two different joins, but not. It is a simply called as inner join, which is also called as simple join. All right, the second join what we have is, let me put on everything so that we'll break it down into each category, and we'll try to work on by using it different tables. Now we have something called full join. Okay, full join. What does this mean? We'll see later, but let me list it out. This is also called as full outer join. Okay, this is also called as, let me put this as a 3. Okay, left join. The next one is after inner and full join, we have something called left join, which is also called as full uh, left outer join. It's not full, it's left outer join. It is also called, if you find somewhere else or somebody's talking about left outer join, it's not a different join, guys. It is simply a left join, which is also termed as a left join. So these are the simply other names, but it doesn't mean that left join and left outer join has a different meaning. No, they are both same. It is called in a different, used in a different style, like SQL and SQL. Yeah. The fourth one, we have something called cross join. Okay, cross join. And the next one, we have something called, fifth one, natural joins. Okay, wherever you go, you will find only 4 type of, sorry, there is one more missing. That's what I'm saying. What is the list is missing? This is 5, this is 6, this is not left, this is right. When we have a left, we have a right. How to remember this? It looks very complicated for me. Not to worry, one is inner, one is full. One is left, one is right. These are the only 4 joins what available in the SQL. Okay, there are 2 additional joins which I'm trying to understand how different they are. Is there really any importance in the live environment as well? Well, let's try to see in action. But these are the 4 important. Wherever you go, you'll find, even in the interview question, what are the different types? There are only 4 types actually, in fact. But if you try to give more information, saying that actually these joins are categorized into 2 types. One is ANSI format, which is called as a new style of format of joins by using an on keyword. Second one is non ANSI format. Okay, always try to spell out what is ANSI stands for. Okay, don't say ANSI, because maybe I'm not aware what is ANSI, right? So non ANSI format, which is an old style. So I'm not going to use a on keyword because I'm going to use a where condition here. So whenever I'm using a where condition, that means it is a non ANSI. When I'm using on, that means it's a ANSI format. So where condition I cannot use on all these joins. Okay, on keyword I cannot use the list, which I'm going to mention here now. I cannot use on keyword on all these joins, which I'm going to list now. So let's see what are those non-ANSI, which is an old style of format, which I keep saying. Okay, the very first one, we have something called equi join. And second one, we have something called non-equi join. And the third one, we have something called self join. All right. So if you look at all these 3, we don't know what is exactly the meaning now. If you look at all these 3, when I want to use these kind types of joins, which are the old style, I can must and should only use where clause there. And if I want to use all these, which are called as a new style, I can use only on keyword. So what does it mean? Of course, when I'm using a equi join, I'm not supposed to use I cannot use on keyword. When I'm using these joins, I cannot use a where condition, as simple as that. Okay, so now we have understood what is exactly a differentiation between ANSI format and non-ANSI format, and what are the different types of joins available. But actual instance, we have only 4 types, that is inner, full, left, right. But we are trying to extend ourselves to understand other joins also, because it's really, really important when if you are trying to explain, because I know only 4 types, and if you start explaining me the categorization of it, and if you try to explain me the more other joins which may or may not be in use, but they are the part of these joins. So when you try to explain me, I'll be really impressed, because that shows the kind of hold you have on the SQL, which is being used on the relational database management system. So let's try to go for the very first example. That is, I'll go by step by step here. The first one is inner join. So let me pick it up from here. I'll use it here. Then I'll try to use my line style to differentiate what this I'm going to learn. Before going further, I want to understand what exactly the inner join. Okay, one thing, the base of any joins is only one thing, joining two tables. If I say two tables, it's wrong, multiple tables rather, let me put that way. All joins talks about only joining two tables with some intention. Okay, my intention is to see that by combining finance table and HR table, I want to retrieve some data. Based on that, I want to do some analysis. What is their salary? What is their tenure? How many people joined in the last 6 months? I want to always I want to answer almost all those questions which are asked by my business or my boss or whatever the stakeholders. So what is inner join mean? Okay, what is inner join mean? How this inner join is going to work? Okay, let's try to give a simple notes here so that you can remember while we are doing the practical explanation. So inner join returns all rows from multiple tables. Let me not say anymore two tables, multiple tables, where join what should I say? Where join equality condition is met. Yeah, that's the right word. So where the join equality condition is met. So what does it mean? We have a table A. I'll show you in the Excel format so that you can understand. Let's not do anything on the SQL. Let's try to understand the Excel first, which will give you a lot of confidence how to work on a SQL. So this is going to return rows from the multiple tables where join where we are going to use the join equality condition is meeting. Equality, what does it mean? Let's see practically now. Okay, now before we go further, there are certain rules to be followed again, because all, as I said, like all these advanced topics follows only golden rules. If you remember the golden rules, that means you are perfect in using all those advanced topics what we are learning now. The first one, let's me put as rules. Okay, the first rule says here, the first rule says here, common column is must. That means what? When I'm trying to go for a table, okay, let's take this example. When I'm trying to combine two tables, the first and foremost is there should be a common column between these two tables. Guys, the explanation what I'm giving right now for one join is same for all the joins. The rules which I'm discussing now is applicable for all the joins. The columns from the both the tables or the multiple tables. Let's assume this is a table, B table, and C table. If I want to join them together, I need to have one unique column which is same. That is employee ID, and employee ID. That's it. That is common column must be there. Okay. Second condition. You'll be seeing these rules the way you spoke with about operators, right? Column data type should be same. Okay, column data type should be same. That means I have an employee ID here, which is an integer data type. Employee ID should be integer data. I have a product ID, student ID, whatever you talk about, that whichever the column you are referring, it should be present in another table also, so that we can join these two tables together in order to get the information. The rest of the columns may not be same, right? This is a finance table. This is a HR table. HR table consists of more of HR related information. Finance is more of finance related information. And when you want to combine, I need to have some unique column in the both the tables. So most of the time when you talk about a employee table, what you'll have is employee ID. When you talk about a student table, college related database information, when you talk about, you'll have something called student ID. If you talk about some manufacturing, order ID, product ID. If you talk about library, book ID, so whatever, some column which is going to be unique in the both the columns. It need not to be the value should be same. Okay, one must really match like 1001. If it is there in the second table also 1001, then it makes sense. So that means the column should be same, right? That is the first condition. And the second condition is quite easy, that the column data type should be same. If not, it will not work. So if I'm failing to meet any of these condition, three columns, which I'm going to say the third one, matching data only from the matching data from both the tables. No. Matching data from both the tables. Yeah, matching data should be there from column from the both the tables. So that is what I was referring. Like you have some 10,000 rows here, we have only 1,000 rows here. But out of 10,000, whatever the 1,000 rows are there, should be matching with other tables so that we can really make that join between these two tables. So that's the third one. Okay, now we are clear. The columns must be same. Columns data type should be same. Matching data should be there so that they can really talk to each other. It will not make any sense. For example, table A is having 5 records, 1, 2, 3, 4, 5, and in another table we have something called 8, 9, 10, 11 records, which are serial number. So when you want to join them, it doesn't make sense. At least some matching record should be there when really you are trying to put that efforts in order to create any report for your organization. So that's a simple rule, and these rules are applicable everywhere. Now, in order to understand this inner more, let me use my Excel. Let me go for the sheet 8 as joins. Let me put this as inner join. Okay, inner join. So what exactly the inner join is going to do? It will return all those rows from the multiple tables where the join equality. This is what I've written. Yeah, returns all the rows from the multiple tables where the join equality condition is met. If when the equality condition is met, then only the inner join is going to work and it is going to get the records for you. So let me not this. Let me go for a paintbrush where I can show you graphically how it works. Probably you have seen in your school days mathematics where you have this set theory, right? Set theory, where we'll have a two circles which is explaining you. Okay, there is a set A and there is set B. Okay, there is a set A and set B. Don't worry about the diagrams here. So, all right. So this is A table, and we have something called this is a B table. Let me make it bigger. Yeah. So this is a A table and this is a B table. Now assume that from the A table we have some thousands of records. In the B table we have some thousands of records. So by using inner join, what is the advantage for me? How this will be really helping me in order to achieve my target? So if I use inner join, what does it mean is, let me put some color. Yeah, this is what the inner join table is. Inner join will try to get all those records which are matching in between both the tables, that is A table and the B table. It is going to get all those matching records. That is what your inner join says, and it has certain golden rules also which we need to follow, right? So this is what your inner join. Let me do one thing for your reference. This is nice to have in your Excel. Okay, let me put it here. All right, this makes sense. Now this is your inner join. Here we have a header, inner join. Now, as you know, it is trying to get the matching records from the both the tables, that is table A and table B. Now that we need to create a table, let's start building a table here. You have taken employee table. Let's take a something called student table, maybe table A, and this is your table B. Okay, this is table A. Let's say instead of table student, and this is course. Okay, who are the students, what are the details, and in the course table you have all those courses with their along with their IDs. Let's assume this scenario. Now in this student table we have something called as STD ID. This is student ID short form. Then we have student name. Then we have something called maybe his location. Okay, hypothetical situation. So here we have CID, which is nothing but the course ID, which course is joined for. Okay, next we have something called course table. Course table, let me put it here. So then again, we have a different columns here. That is, what is the course ID we have? And what is the C name? That is a customer, not customer name here, course name, rather let's take as a course name. And we have something called, what should we call it? Okay, let's say course fee. Okay, I'm giving short forms here. Don't get confused. CID stands for CID stands for a course ID here, and C name stands for course name. C fee, nothing but fees. Now let's start putting information into this so that we can really build two tables, which will give a clear understanding how this really works. Okay, once we have student ID called 1001, we have 1002, we have 1003. Okay, let's assume we have student name like let's take as uh, Ronnie, and we have something called Monty. Then we have something called Nani. We have three different students, and we have something called 1004. We have something called Nilima. Okay, we have four different students we have in our first table, and their location is something called Hyderabad. This is Chennai, and this is Chennai, and this is Delhi, and this is Mumbai. Okay, so we have a different four different locations as well, and the course ID. Course ID is nothing but, let's assume this is 10, this is 20, this is 30, this is something 40. Okay, now let's go back to the course table. Okay, in real time the situation might be different. Now we are trying to understand the concept. So I'm trying to make the table, though it's look a simple table, but trying to make it complicated so that we can really start working on these joins here. So we have something called CID. CID is nothing but course ID. We have 10, we have 20, we have 40, we have 50, we have 60. Okay, these are the different courses what this particular institution or some organization is offering for us. Course name is something called, we have Excel, we have something called VBA, we have SQL, we have Click, we have something called uh, Tableau. Okay, these are the different courses. And whenever I want to talk about Excel, I'll always talk about 10. 10 stands for the course ID. And what is the course fee here? Let's say 1000, this is 2000, this is 500, this is 1500, this is something called 3000. So these are the different prices, fees structure for each course to be taken. So if I want to understand this guy, Ronnie, who's staying at Hyderabad, which course he has opted for, he is opted for course called Excel, and its fee is 1000. So when I want to combine these two kind of tables, so let me put some borders so that you can clearly see the header part sections. Okay, now we have something called now, as I said, the very first rule says that we need to have one common value, common column, okay, which is of a same data type. We have a CID, here we have a CID. What does it mean? Like the column name should be same, no matter if you have something called course ID, okay? It doesn't matter, the column should not match all the time, but the column value should be same. And the second condition is your column data type should be same. If it is, this is string or character or your varchar, and this is your integer, float or something, it's not a right combination. So because the rule says I need to follow it, like there are few rules. If you break any of the rule, your condition fails. So here, simple table, as you're seeing, like 10, 20, we have 40 and 50, 60 as well. Okay, something is missing. Okay, if I want to know this Nani has opted which course, actually he is a student. He is a student, but if you look at, he has not opted for any of the course in the table, right? If you look at Monty, he's from Chennai, he's uh, 20 is the course ID which is opted for, and is looking for a VBA and is supposed to pay fee 2000 already paid. This is a course free structure what we have in our organization, and every course has its own unique ID through which I'm going to identify as a column reference. So you can think about like this. This is a parent table which has something called a primary key, and this is my foreign table, that is a child table which has a foreign key. So the first and foremost condition people insist on saying that, like, if you want to combine two tables, there should be always a relation between these two tables. It's mandatory. At the same time, it's not mandatory. Why it is mandatory and why it is not mandatory? If you're working in such kind of environment where the data is being inputted in every minute or every second, then it becomes important. We need to have a relation, because so that we can make the unique uniformity of the data, right? That's what we have seen with the constraints, with we have we have seen with the primary key and the foreign key. But here I'm trying to take a hypothetical situation where we have the data already existing 1 month lag. The data is already there. I'm trying to combine to get the result and analyze further to create a report for my organization. So this is what we have the data now. Quickly, let me create a table without taking much time. So I want to go for view. I want to go for object explorer. Then let me create for a go table, this new table called a student. That is, what is that? std id. The data type should be integer data type. The next column we have something called student name. Then we have varchar 50. Then we have something called location. Then we have something called location is always varchar, and size could be 50 or something. Then we have some course id. Okay, I'm taking as, let's take a different name. So simply I'm saying ID. There I'll say course ID, or here we can say course ID, and their ID doesn't matter, because the column name, it's not mandatory to match. As I said, like, the column value should match, at the same time the data type should match. Okay, need not to be the same column name. That there is a big debate. The column name should be same. No, it's not mandatory at all. The column name or different doesn't matter. Course ID is something called integer, so I would like to give integer. So now I have 4 different columns with 4 different with a different data types here. Once I say this, I want to give a nice name to it, student table, as a table name. Now quickly close it. Now refresh your, without refreshing, don't try to go for a design. Just click on it, then click on the tables, and see you have the table. Now once I go to the design, we have this design pattern what you have designed. Now I want to insert a data. So when I want to insert a data, we need to go for edit top 200 rows. So up to 200 rows, so you can just quickly copy and paste. That's what we have seen in the previous example. Because I don't want to type it, simply paste it. That's it, your data is ready. The last line is showing null because it's still expecting, you may be expected to write something, but I'm not writing anything more. It's as good as null, so it's nothing. So once I close it, the data is ready in the student table. So let me quickly create again one more table that's saying that new table, and this time the column name is, as you already mentioned, as course ID there. So let's not use course ID this time. Let me put a different one, that is ID, and this time it's an integer. Next would be your CNAME, nothing but your CNAME is course name, right? Course name. Then we have something called varchar and 50. Then we have something called the fees, C fee, and this is going to be integer, obviously. Okay, now let me close this and stay. This is a course underscore table, which is a course table. Your table is ready. Now, just before doing anything, always try to refresh and see if the table is ready. Now go for your course table. But if you look at this course table, we have the columns, but nowhere I've specified what type of constraints I want. You can put all those constraints which you're looking for. Null, not null. Null is by default anyway, as we have seen practically examples how to use null. Even if you don't use null, by default is a null. That's how the RDBMS is designed. So not null is not, it will not allow you not null. Say, and the second one is, your third one is unique. You can use a check constraint. We can use a primary key. We can use a foreign key. We have all those constraints to enhance your data quality into your data. What kind of data should go into a table that you can impose here. So we have the straight away table here because we are learning joins. We want to create a simple table which will explain us how to work on this. Now, let me try to run both the tables and see, okay, we have the course, we designed the data. No, we haven't. So let me go for design, select top 200. Let me go for course table, edit top 200. Let me not write anything. Let me simply dump this and paste it here. All right, my table is now ready. There's no need to save, as you know, like by default, it's get saved everything. Now I want to select star from, okay, this table, student table. Now select star from. Always better to get your table familiar before you start writing anything. That will give you a complete hands-on. There's no need to think much when you're running, writing queries or combining multiple queries. So I just want to analyze some more information here. What kind of data I have here? First one is student ID. In the second table, I have an ID, but does it works? Yes, it should work, right? Because this ID and course ID is matching. The column values are matching. The first one, we have a student ID, which we don't have a student ID in the second table. So I don't consider that student ID to be a common column. So S name, again, it's not. Location, it's not. Course ID is something which is a unique. And here I have an ID, which is unique. So that unique in the sense, I mean to say combination of column, that is a common column in the both the tables. So that means I am very good to go with these two tables to start using my all joins in this table. So that is this ID and this my course ID. Now you are familiar with the table structure. You are familiar with how many columns you have. That is 4 columns, 3 columns we have here, right? If somebody is looking for, can you tell me, Ronnie, from which location and which course he is taken, and how much he is supposed to pay the fee? It's little difficult to answer this question because I have these details in the two different tables. So for that, I cannot use simple select query in order to get retrieve this information, whereas I need to combine them by using your joins here. So how my question is answered is like you are going to select visually by looking at the table. First, Ronnie, he's staying in Hyderabad. Okay, he has taken course 10. Okay, what is 10? Let me see. 10, 10, 10. Okay, 10 is Excel. Okay, by the way, Ronnie is from a Hyderabad location. He has opted for a course called Excel, and he is supposed to pay fee 1000. This is how you're visually looking at the data and you're talking about it, right? So now let's start using our sophisticated, I can say, beautifully written these joins. The very first join is talking about inner join. So let's see how the inner join works. So what the inner join, before actually I'm writing the inner join, you should know what is inner join meaning. I mean, what it does actually, what is a, how does this is inner join is going to help me. If you know that while writing, it will be very easy. And inner join is related to what? It is an ANSI format. That is a new style format. That's what we understood. And it will always goes with a keyword called on. Okay, we don't know how the syntax is now, but on, that is something which you need to keep in the mind before you actually write the code. Inner join will simply, it's also called as simple join, as I've written there, returns all the rows from the multiple tables if the condition is meeting. So that means if the condition is meeting, okay, we have a graphical presentation here, right? By the way, if in the A table and the B table, if the matching records are there, it is going to display. So what are the matching records? Do you have any matching records here, by the way? Let me see. Ronnie is matching anywhere. How do I match? There is no such student name here, but how do I match? Maybe with a course ID. Course ID is matching here, right? So that means this is a matching record from the both the tables. Is the second record is matching? No, not anywhere. Yes, actually 20 is matching. 30 and 30 is not matching anywhere. 40 is matching. So that means these are the matching records. So let me highlight this. This is 1, and we have 20 is also matching, and we have 30 is nowhere there, and 40 is also matching. So these are the common these are the common columns which are matching in the both the tables. So when you're trying to retrieve these information from the both the tables, for whichever the columns we don't have the information, it will retrieve as null. Null, still confusion. Null is something, is not a blank, right? It is not a zero either. It is called as a missing value or a placeholder where it is going to be filled in future. So that is what your null is all about, right? So what are the highlighted cells right now, or rows rather, are the matching records from the other table. So let's try to understand this more through the help of SQL now. Now I have the two tables. Now I know graphically and as well as through the SQL how this tables behave and what are the structure, size, shape of these tables. Like we have 4 records in the first table. We have how many? We have 5 records from this table, right? So 5 plus 4, we have almost 9 records. So 9 records, when I actually use inner, what happens? Does this really retrieve only matching records, or it is going to retrieve all the information? So let's try to see practically this without taking much time, because we need to see the even we need to see the how the syntax look like, because I'm more interested in understanding the syntax. If you understand this one single syntax, all the queries which I'm going to talk further in the next half an hour will be same. So let's try to understand the syntax itself. Syntax, okay. The syntax goes like this, like select columns from table 1. Okay, that is the first line. As simple as my first query of select query. Then here we need to use your join. What join? I don't know, because we have 4 types, right? Actually, primarily 4 types. Now we know like 6 types are there in the ANSI format. I'm simply putting join. Which join I'm not mentioning, but I'm talking about syntax here. Join and table 2, because we want to join the table 1 and table 2, but with a what keyword? That is on. On. Here we need to use your condition. Condition in the sense from both the tables, which is a common column which is matching. So let me put this way. From the table 1, my matching column is course ID, which is equals to table 2 dot your ID. This is your condition. This is your condition. Okay, so how the syntax goes is, if you understand these simple 3 lines, that's why it's called as a new style format. That's why it's so simple, neat, and without much complications. Either you can say select columns here, or simply you'll say select star, right? Obviously, it's up to us like how many columns you want to retrieve. So select star from table 1, join. Which join? You, of course, you are going to mention it's whether inner join, left join, right join, auto join, or cross join, or we have what else? Natural join, right? So any join can be used here, but before that, I want to first test what is inner join, how it really works in the real time. All right. All right, this is how it works. So whenever you're trying to use any join for that matter, it doesn't matter how many columns it should have. If the first table may have 50 columns, the second table may have 10 columns, the third table may have 150 columns, doesn't matter for me. What matters to me is whether I have a common column in between them so that I can talk to each other. When a group of people wants to talk to each other, they should share one common column, common agenda. Okay, one common interest. If you want to have a debate, there should be a one common interest. In the same way, here we have a one common column which can talk to multiple tables. So every table should have a common. If not, you need to create it physically, forcefully. You need to create one common column, which then only you can start joining them. If at all, if it is a requirement, sometimes we forcibly insert a separate column for it to join to some other table. Okay, it more or less looks like a VLOOKUP, but let's not compare with the VLOOKUP. VLOOKUP gets one column, again one column, again column. Here at once I'm going to get all those columns which I really looking for. Okay, it's kind of a VLOOKUP only. Still, you can say this 10 is trying to look into this table, or this 10 is trying to look into this table and getting the course. This 20 is looking into this table and trying to get VBA. This 30 is trying to look here. It found nothing, return 0. Okay, writing nothing, NE or anything. 40 is trying to look into this table of this column and trying to see whether I have the 40. Yes, I have 40. So this is a line, should be here. That's it. So this is about the inner join. We need to remember only one line of statement. What is inner join? Inner join is nothing but get all those records from the both the tables with a join of equity condition. That means when they are really matching with the common column, then only it's going to get. What is the common column here? Course ID. So 10, 20, 40 are matching from these records. So let me highlight the same here. That is, let me just do it quickly. There's 10, and we have something called 20 is also matching. Not really. 20 is also matching. Then 30 is not matching. Then we have something called 40. And what is missing? In this table, 30 is not matching. From this table, we have courses. There are a lot of courses actually which we are offering, but all the courses are not opted by our participants or the people who are in the colleges, not everybody is opting for Tableau or Click. Only few people who are opting for Excel, VB, and SQL. Maybe tomorrow a few set of people also like to join for Tableau. So I have already the list with me. So if somebody joins, no matter if somebody is joining with one more, I've entered one more row, and course ID I can enter if it is available in my course list. Okay, I can give you only that if it is available with me. So that means I have 10 to 60 courses with IDs. So if somebody is asking something called related to Oracle, I don't have here. So obviously that course is not available. I cannot create any such I cannot take any information from the participant in going forward. I'll start or something, like we cannot take anything into consideration. So that's how it works. Like whatever the you have a static information, that's based on static information we are trying to combine it. This is a left table and this is a right table. So student and we have course table. So the syntax is very simple. Select from the table and join, and this with a condition. So let me quickly write the first statement. Select star from which table? That is a student table. Okay, then I want to use join. Which join it is going to be? Inner join. Okay, it's grayed out. It's grayed out completely, which is correct. Inner join, which is also called as what? Inner join is also called as a simple join. Okay, we cannot write simple there, but it's also called as inner join. So we cannot call as a simple here. Okay, there's no such terminology to be used as a join there. Now I want to use again a same statement. Select star from which table? This is not a student table. This time I want course table. So let me use this one. So unlike your operators, what you learn, you cannot use simply select star from this table and select star from this table and use inner join in between that, because these two tables are not sharing the same size and height and width of the tables, right? It has a different column. So it's not the way to use, because we got used to now with the unions and whatever the four operators we learn, we got used to using in middle. Yes, of course, you can use in still in the middle, but not this way. So how I'm going to use this now, inner join. Now I'm going to say inner join the table name. Now my table name is this because this is table 2. Let me go with the syntax. Select the column names from table. Okay, I'm done my job. Now join. Okay, I joined it with, because I'm just learning inner join on which table. Okay, this is a table. And what is the keyword I need to use? On, because on, you can see it's a converted into a blue color, which means it's a keyword. So on can be used only in on ANSI format, not on a non-ANSI format. On is a keyword which is evolved as a new style format of joining together, right? On, after on, what is that? I need to use something called joins, right? So let me say course ID equals to ID. That's your column table, right? Your columns. So let me run this, and what happens? Let's see. Okay, we got exactly the columns which are matching from these two tables. Actually, this is not the way to give your query, because whenever you're referring your columns, we should always accompany with their column tables. So for example, this course ID is coming from which table? Your course ID is coming from your course table, right? So let's say this is course ID is coming from course. Okay, and this one, your student is coming from dot, we have course ID. This is how we are supposed to give along with the table names. But you're saying it's mandatory to give the table name, but without the table name also you got the output already. Yes, I got the output. The reason being the column names are different, so it is able to differentiate. Okay, this column is from this table and this column is this table. What if these two column names also same, for example, course ID and course ID, then it will get confused which course ID you are talking about. Are you talking about student table, or are you talking about a course table? So that's why if you have a two different columns, it's not really important to provide the table name prefix as before the column name, but it becomes mandatory to prefix the table name before the column name when the column names are different. Column names are different, right? Both are same actually, but the column naming convention is different, course ID and course name. So let me run this and quickly see what happens. It is trying to get you all those required columns from both the tables, which are matching 1000, 1002, and 1000. Is it true? 1000, 1002, and 1004. That's how we got the record from both the table, but it looks little weird. This is not the really expected result to be. I want only a specific columns from these tables. I don't want the ID maybe. So how you're going to specify that? So in the star, remove that. The very same old, select from which table you're talking about, student. So what are the columns we have in the student table? We have student ID. Okay, maybe I require std ID. Okay, then I want to say comma. Then we have something called s name. Okay, s name. Then from the second table, I want the course name. So these are the few fields which I'm looking for, because this is a right combination which I'm saying now. Student ID is related to first table, S name is related to second table, third table is related, C name is related to your second table. And the same time, I want to know the fee also. So you're trying to make it more complicated now. C fee. Okay, 4 columns. Now let me run this and see what kind of situation we are in now, because we don't want the entire table to be displayed just like that. You want to display only the information what you require. But it most of the time, the tables are not so simple names in the real time. It's very lengthy. Instead of using table names like this, what you can do is, we learned a concept called alias name, right? So let's say this first table as A, this second table as B. What does it mean? There's no need to give any more the table name. Simply say A dot, and this is B dot. This is what you call as alias name. Why I'm giving alias name, by the way, because I don't want to keep writing the table names, big table names before my column names. So simply after your actual table name, I'm giving as A, doesn't matter. Without as also, it works. By default is an as only. When you're trying to use after your table name any text, it will take into consideration as alias name. Alias name is like giving another name to your table. So this is A for me to understand easily, or else you can say something like S, which stands for student. This is course, you can say C. So I'm making it simple, A and B. I always use A and B for my easy identification. A stands for the primary table, B stands for the second table. So when I run this is where I land up. Okay, now I join two tables with a simple inner join in order to get the matching records from the both the tables. So now let's quickly move on to the next join, that is left join. Okay, in order to understand the left join, what I'll do is, again, I'll go back to this and I'll try to create visually how it looks like, so that we can understand more about this. So for that, let me select this, and 2 circles I require. What are the... All right, so let me take a black color, and for 2 circles, 1, and I'm going for 1 more circle, this. Now, your left join always talks about, by visually only, you should be able to understand what I mean. Then we'll get into the concept. So what exactly the left join is always talks about is, the left table will be intact without any changes. That left table will remain same with all the records, irrespective whether it's matching or not, doesn't matter. Left table is as is, with only matching records from the right table. That is what your left join is talking about. This is A table. Oh, this is not right. This is A table. Okay, this is A table and this is a B table. That's what our understanding. So let me quickly copy this and put it in the next sheet of your Excel. Let me say this is left join. Okay, now let me remove this and paste it this. This is your left join concept. Your left join table will remain constant, and whatever the matching records are there from your right table will come and settle down in the left table. So that is what it means. So obviously, when the column names are not matching, how the records are going to come and settle down here. So that means it will have all these columns intact without any change, and whatever the new columns are getting added to this table will be added, but the rest of the values which you don't have the information will become null. That is what the whole essence of your left join. Left join will remain constant, but it will retrieve only, you can see the field color, it will try to get only matching records from the right table. That means you have the four lines. From this, it will try to get only matching records of that table. So let's quickly do this exercise without writing anything as such. Only a simple change will make entire into inner change to left join. So let's make it as this left join. It will not take much time. Left join. This is your inner join. All right. So left join, what it does, left, just need to remove left inner and put it as left. Now, when I run this, what happens is it's trying to get all those matching records. Let me copy this and copy with headers, come to your Excel and paste it here. Okay. Now let's try to understand visually here what exactly the left join is doing. Your left join is intact. If you can see 1001, 1002, 1003, 1004, no matter, it is same. There is no change. Even the names also change. If the C name is coming from your second table, and the course fee what we have for this Excel is 1000, and why it is null for the Nani? Let's see, 1003, which is a record which is not existing in this course list. There's no such record code 30. So what it is doing, there's no such course name, so it is giving null. When there is no course, obviously there is no fees for that, so it is showing as null. So this is what you call as left join. Left join always keep the information intact without any changes by combining the right table, matching records only. That is what your right left table does. Now let's quickly look at the right one, which is quite opposite to this one. Okay, which is a quite opposite to this. So what we're going to do is simply take a one more circle and one more circle, that is a one set with another set. This time I'm not going to do something different. It's the same, but the coloring part is different. So let's see what is the coloring part. So let me select the same color so that you can, yeah. So that this time the right table will remain intact and it will get all the records, matching records from the left table. That is what your right join stands for. So let me quickly copy this before. Okay, we don't have the set. This is right join. Okay, let me remove this as well. So because we are going to get a different output here, let me remove this. Let me paste the right join here. This is your right. Now, beautifully, we can understand with the visuals, left join what does, inner join what does, and right join. Now we are talking about a right join, how it is going to work. So if you want to work on right join, actually, if you understand the inner join concept, the way I've written, it's the same case. This time I'm going to use a right. Okay, here I'm going to use as a right instead of left. Now, when I run this, now I want to compare with the raw data so that I'll understand. So let me copy everything and paste it as a raw data here. Now let's try to analyze with the data. The right table is intact, right? And wherever the data is not available, it is showing as null here. So we have a Excel, we have a VBA, we have SQL, we have a ClickSense, we have a Tableau. That means the right table is intact without any change. But corresponding to this right table, left table, whatever the information I'm supposed to get, I'm getting. For Excel, who is available for the Excel? 10. Okay, 10. We have Ronnie. Yes, Ronnie. If you for 20 VBA, who is available for 20? It is Monty. It's there. For SQL, Nilima is there. Okay. For Click, nobody has joined. So we don't have any such student. We don't have any student ID also because these two courses nobody has opted. So your right table is still intact. This is how I can see. And the left table matching records only it is getting, and rest of the records for which it is not getting the data because it has to be intact without any change, right? For these two records, there is no data, so it is getting the null information there. That is what your right join. Now let's quickly look at the last one, the fourth one. That is, we have seen inner, left, and right. Then this is called as a full join. Okay, let's see. Quite interesting. Full join is makes sense in most of the cases, but somewhat I feel it gives the result correct only, but it may not be suitable in all the cases. What happened? Okay, this is your full join. Okay, in this full join, let me remove this. Let me also remove this. Now go for your full join presentation. Now let me quickly bring on to this circle shape. One, and we have one. Now what is full join here? By this time you already guessed it, right? That is, full join always refers to your left is intact and your right is also intact. with a matching or not matching records. Okay, this is what your left join talks about, your full join talks about. That is, you have two circles, the way we have for others. Now this time, the what happened? The left join, right join, inner join, full join. Yeah, got it. So now when I put the color for here, that means left, this is right. Okay, when I'm putting the color here also, what does it mean is it's trying to get the matching records from the left to right and matching records from right to left. So that means whether we have matching or not, whether we have duplicates or not, doesn't matter. It will get all the records presented in the two tables. It's going to get all. For whichever the data we don't have, obviously we are going to get the nulls. So let's see what is the how full join is going to work in practically by putting instead of right, let me put simply full join. So when I use full join, full, you can use full or you can say full outer join, right? So doesn't matter. So when you use a full outer join or full join, so when you run this, what happens is it's giving you the data. Let me copy this and copy with the headers. Yeah. So when I paste the data here, how the data is looking. Left join, it is trying to keep that left table intact. Right table is trying to keep the right table intact. Inner join is getting only matching records from the both the tables. Outer join is outstanding. It is different. It is whether you matching or not. My job is to get all the records. That's it. That is what it's saying. We have 4 records. You can see here 4 records from the left table. Yes. From the second table, we have 5 records. From the second table, we have the 5 records. For whichever the column values we don't have, for example, 30 is Nani, and from is Delhi. From if you look at Nani information, in the left table, we have this information, but in the right table, we don't have any corresponding information, but still it is getting the data. That is, it is getting the complete information from the both the table. That is what you call as a full join in the one of the type of join in the joins. So this is your joins in the full.